just after 2 p.m. Eastern Time. We're going to go ahead and get started. I want to welcome everyone to today's webinar, the 2017 NEC Significant Changes in Review, Part 1. I'm your host. My name is Timothy Johnson. I'm the digital editor for Electrical Contractor magazine. Just to start a couple of housekeeping things, the audio for today's presentation should be coming through computer speakers or headphones. If you prefer to call in, there's a toll-free number in the event info panel. Should be there at the top left. If you have other difficulties, please reach out to me via the chat window, and I'll work with you to get things sorted out. Also, please note that today's presentation is being recorded. If you miss anything or something comes up and you have to leave, you can come back at your convenience. Finally, there's going to be a Q&A at the end. So if you have any questions during the presentation, feel free to submit those questions in the Q&A chat box. So now on with the show. Today's webinar is all about the 2007 NEC Significant Changes, and it's part 1 of a 2-part series. Part 2 will be live on December 1, and at the end of this event, you'll be taken to Part 2's registration page so you can sign up if you haven't already. Our presenter is Michael Johnston. He's NECA's Executive Director of Standards and Safety. Mike is chair of the NEC Technical Correlating Committee. He served as principal representative on NEC Code Making Panel 5, representing IAEI for 2002, 2005, and 2008 cycles. And he's currently the chair of Code Making Panel 5, representing NECA for 2011, 2014, and 2017 NEC cycles. He's also a member of the IBW and has experience as an electrical journeyman wireman, foreman, and project superintendent. Mike worked for the IAEI as the Director of Education, Codes, and Standards for almost 10 years. He also worked as an electrical inspector and electrical inspection field supervisor for the City of Phoenix. Mike is an active member of IAEI, the NFPA Electrical Section, Education Section, and UL Electrical Council, and National Safety Council. And after all that, he still finds time to contribute to and consult for Electrical Contractor magazine as one of our code experts and our code comments columnist. So I want to thank everyone for attending. Now I'm going to hand it over to Mike to get started. So Mike.
Thanks, Tim. Thanks very much. And once again, it's a pleasure to be here and work with Electrical Contractor magazine to take a look at some highlights, what's changed in the 2017 National Electrical Code. We're on the heels of the code being published. It was published in September. It was actually issued by the Standards Council in August. And a lot of work went into that by a lot of the NEC code panel members. And have to give a shout out to all of their efforts. It's a lot of work that goes into the code as we see it when it's finally published. So happy to be here with you folks. Before we get started, we would be remiss if we didn't acknowledge our sponsors today. We have 2 key sponsors that we work with quite a bit at EC Magazine and with NECA. Fluke and Siemens stepped up to sponsor this event, so we appreciate their support, and we also appreciate the attendees that they may have brought along the way with them. Thank you for our sponsors. So a little general information, and then we'll get into some of the specific changes. Each cycle, each code development cycle, there's a number of public inputs or code proposals, if you will, that are submitted to NFPA, and a number of comments on those proposed changes that the committees act on. And this slide just shows you, kind of quantifies, if you will, the number or the quantity that these code panel members had to deal with. Just over 4,000 proposed changes, public inputs, and that resulted in about 1,235 first revisions. That's the first stage of the cycle. And then second stage of the cycle is the comment period, where public comments are submitted on those changes. There were about 1,513, and that resulted in about 559 second revisions. This cycle, like other cycles in recent years, produced 5 new articles. There were actually 9 new articles in the NEC that were proposed, and as a result, 5 new articles emerged in the 2017 NEC. And we're going to talk a little bit about those articles in just a moment, but I do want to mention a couple of things. Right off the bat, you can see an icon version of a portion of the cover of the NEC, but I also want to talk a little bit about the significant changes to the 2017 NEC textbook and training material that was produced and published by the Electrical Training Alliance. The artwork and photos that you're going to see used to support this program today are derived from that publication, and I'm proud to have co-authored that publication with Mr. James Dollard, and Dollard is the safety coordinator for Local 98 and the Philadelphia Electrical JATC. It's always a pleasure to work with Jim and the Training Alliance to produce this product. And I should also mention that Underwriters Laboratories is also a contributing developer to this product. So let's talk a little bit about, well, before we talk about these new articles, let's talk about change in general. And I'm reminded of a quote from W. Edward Deming, and his quote on change goes something like this: "Change is not necessary because survival is not mandatory." So I leave that with you while we're looking at these changes, and leave you to ponder that thought from Deming. And it's so true. We have to be flexible and understand and apply the changes in our day-to-day operations, especially when it comes to legally adopted rules that we all have to abide by in the NEC. Those 5 new articles that I talked about in the beginning, one in Chapter 4 deals with fixed resistant and electrode industrial process heating. This is a larger scale process heating equipment typically found in industrial facilities. And the next 4 articles are related primarily to industry trends, what's going on in the field related to energy management, load leveling, handling demand response, and so forth. Article 691 was very adequate for several cycles, but actually fell short when we start having to apply rules to large-scale photovoltaic power production facilities. So this cycle we see a new Article 691 to handle those needs. We also see 3 articles in Chapter 7, and when you see something in Chapter 7, you should automatically think system. It's not just equipment, like battery, for example. That would fall under Article 480 as equipment. Battery certainly is one component of an energy storage system. But 2 new articles that were the result, actually 3 new articles that were the result of 6 years worth of work. That's 2 NEC development cycles. Article 706 dealing with energy storage systems. 710 deals with standalone systems that are islanded systems, not grid connected, off grid. And then Article 712, direct current microgrids. These are all trending topics and trending components in our industry that are providing many opportunities for electrical contractors, and they are key components when we're dealing with handling Department of Energy initiatives, smart grid directives from the government, and so forth. So new articles, it's interesting, we have all this new information that appeared in the NEC, and the NEC typically from cycle to cycle doesn't get any smaller. And I actually compared the page count between the 14 edition and the 17 edition, and the 17 edition has 874 pages, and the 14 edition had 910. The difference is, found out later from NFPA, that the font size was changed. But typically from cycle to cycle, we're looking at usually expansion of the NEC rules. The introduction is provided in Article 90, and this provides a roadmap for how the code is structured and how it should be applied and so forth. Scope issues are covered within Article 90. So a couple things to mention here that were rather interesting. Panel 1 had some interesting changes, as we'll cover shortly. The words, well, under the scope, 90.2a, which deals with what's covered, under the scope, the words "and removal" were added in subdivision A. And what that means is the NEC recognizes not only equipment and conductors that are installed in compliance with the NEC, but also those that may be removed in compliance with the NEC. And an example of removal might be temporary power and lighting must be removed by a code rule once the project is completed. There are also other requirements for removal within the NEC. Typically in Chapter 8, when you have abandoned communications cables that are accessible, those are required to be removed. And there's other removal requirements such as in-for cellular raceways that contain conductors. You can't just abandon those conductors in place. They also are required to be removed. So the NEC not only addresses installation of conductors and equipment, but also deals with removal. And the scope was modified accordingly. 90.7 gets into factors that are used by inspectors and so forth to achieve an approval of an installation. There's a new last sentence in 90.7 that has been added that deals with and clarifies suitability of equipment, it being related to application of requirements within standards that are consistent with NEC rules. So in other words, we're talking about examination of equipment. It often involves the equipment that's built to appropriate product standards. And those product standards need to be compatible with the installation requirements in the code. There are many standards in the North American safety system and beyond, worldwide standards. Some are totally compatible with the NEC and others are not. And this change in 90.7 and associated informational note provides the needed clarity that the conductors and equipment and the standards they're built to must be compatible with the installation requirements of the NEC. So we move into Chapter 1. Chapter 1 includes definitions of words and terms. It also includes general requirements in Article 1. And the first change you'll notice is an expansion of Article 100 because multiple definitions from Chapter 5 were relocated into Article 100. And this is to align with the requirements of the NEC Style Manual. And when you see that happen, if it was a definition from Chapter 5 this cycle, relocated into Article 100, you'll see the words "as applied to hazardous classified locations" in brackets following the word or term that's used within each of those definitions. And the equipment that we used with this change is a typical purge and pressurized panel board inside an enclosure that makes it suitable for installation in a hazardous paren classified location. There's two new definitions, and these are important to not only inspectors, but they're also important to contractors, owners, and so forth. They're definitions of the term field evaluation body and field labeled. And they have a direct relationship to the standard in which they're derived from, which is NFPA 790. That's the standard for competency of third-party field evaluation bodies. Oftentimes, inspectors require third-party listing or product certification as a basis for approvals. And if equipment comes in and doesn't bear that indication, or if there's evidence that it has not been certified or listed by a qualified electrical testing laboratory, oftentimes an inspector will provide a field follow-up report, and it often results in a field evaluation and associated report. So NFPA 790 has defined terms, field evaluation body and field labeled, that are now included in the NEC because they're used within rules that are governed by Code Panel 4, specifically in this case for large-scale photovoltaic systems. And one of the graphics that we have is a simple graphic that would represent an example of a field label that would be applied by the field evaluation body. And there you can see the actual definition. It talks about an organization that performs field evaluations of electrical or other equipment. Field labeled, and it talks about equipment to which a label has been attached by the field evaluating body, and it indicates that the equipment and materials have been evaluated to appropriate product standards and are compatible with the NEC. So staying with the approval process, Article 110, specifically 110 Section 3, has been modified to include a new subdivision C dealing with listed and product certification. The title of 110.3 in general includes the words product certification, and the new subdivision C gives an indication to users of the code what listed actually means. And it means testing and evaluation by a qualified electrical testing laboratory that's set up to perform such evaluations for acceptability in the field. An interesting and valuable component of this change is the informational note that follows subdivision C, and that informational note provides a reference to a list of qualified electrical testing laboratories that is published on OSHA's website. So if jurisdictions are out there and they're struggling with which qualified electrical testing laboratories to accept in their jurisdiction and approve on that basis, they can go to OSHA's website and find that fairly inclusive list of those qualified electrical testing laboratories that OSHA found acceptable. And here's an example of some equipment that bears a product certification mark, and in this case it refers to the appropriate standard to which the equipment has been evaluated. Moving right along in 110, Section 16, not a new section to the NEC. This is the section that deals with arc flash hazard warning markings. A new subdivision B titled Service Equipment has been added and an associated informational note. And what this new subdivision requires is for larger equipment some additional installation-related criteria or detail for determining arc flash energy levels and required PPE when the table method in NFPA 70E is utilized. So what you're going to see in this subdivision is a 1200 ampere threshold. So that's an indication right away that you're dealing with services where you've got a higher energy level. The label needs to meet the requirements for durability and the ANSI Z535 criteria. That's what the reference to 110.21b gives you. And it also has to contain, in 2017, the nominal system voltage, the available fault current, the clearing time of the overcurrent device, the service overcurrent device, and the date the label was applied. So these are all installation-related criteria that are now required to be on the arc flash hazard warning label. What we have as an example to show you what the expansion was, in the previous editions of the NEC, everything above the highlighted text is what was required by the NEC, which was just basic information about arc flash hazard warnings. The expanded requirements in the 2017 are highlighted. The date the label was applied, nominal system voltage, available fault current, and service over current device clearing time. And those are all factors that are used when you're applying the table method of establishing incident energy levels and levels of PPE that must be worn in a given work practice. Something else that's new in the NEC that is probably long overdue, if I can interject an opinion on it, it's not related to anything new that's going on in the industry. It actually relates to ongoing practices of refurbishing, remanufacturing, or reconditioning electrical equipment and then putting it back into service. So 11021 was restructured into a subdivision with a list item 1 that contains all of the manufacturer's marking requirements that were previously there, but a new list item 2 was added and a new exception, an informational note. And this new list item 2 provides marking requirements for reconditioned equipment, including the responsible organization and the date of the reconditioning. So in other words, there's some more traceability, if you will, and there's some more responsibility for those organizations that would be responsible for the reconditioning of equipment that is put back into service. This is going to be valuable for inspectors, for installers, for designers, for owners, and others who sometimes run into problems with legacy equipment where you can no longer buy new equipment to be installed in existing equipment that is energized. This is not something new. This is going on in the field. This is the code's first attempt to recognize and put requirements in place for reconditioned, refurbished, and remanufactured equipment. We've got a graphic that shows what we're talking about here. For example, if this circuit breaker were built to an appropriate standard and it was remanufactured, it would obviously have to be remanufactured in accordance with the provisions in the applicable product standard. And then the name of the remanufacturing company, oftentimes it's a manufacturer of that equipment, the date it was reconditioned, and the organization's name that was responsible for it. So a new labeling requirement there for remanufactured equipment. 11024 is the requirement to mark service equipment with the maximum available fault current, and we all know that that requirement is in place in the NEC too, and it's related to equipment rating purposes, to make sure that equipment is not used beyond its capability or its limitations relative to available fault current. A new last sentence was added in 11024A, and it deals with calculations that are made to determine whether or not the equipment maintains a suitable short circuit current rating for its use. That new sentence is, the calculation shall be documented and made available to those authorized to design, install, inspect, maintain, and so forth that system. So the AHJ certainly has a little bit more leverage, if you will, in getting information to ensure that the equipment being installed or worked on maintains its rating as required by 11024. And the graphic that we use shows 3 labels. You've got a manufacturer's label on the top. You've got the 11024 label, the black label in the middle there, where it shows maximum available fault current at 45,000 amps and the date the label was installed. The arc flash warning label below is the label that would be required by 11016. Section 11026 is all about providing workers minimum amounts of working space about equipment. And 11026A sees a new list item 4 titled Limited Access added to address areas above a suspended ceiling or in a crawl space where the equipment installed in those locations would be likely to require servicing while energized. So this new list item 4 has the specific criteria that must be applied relative to the minimum amounts of working space in those areas. And this actually entered the code last cycle in section 424.66 for duct strip heaters. That was a change in the 14 code. And Panel 1 acted favorably to expanding that requirement beyond just duct strip heaters because there's other types of equipment installed in crawl spaces and above suspended ceilings that would require the working spaces specified in 110.26. And the graphic that we show in this program is a Training Alliance graphic from the book as well, but it shows typical duct strip heater that would require that minimum space for working on while energized. And it's a good example of equipment that's intended to be worked on while energized, especially in a troubleshooting mode. 110.41 is not new information to the code, but it's an expansion. If you want to write down section 225.56, for outside feeders and branch circuits, inspections and operational testing was required for medium and high voltage circuits and equipment. What's happened this cycle is a new section 41 has been added to part 3, which deals with those medium and high voltage installations of feeders, circuits, and associated equipment, and a requirement for pre-energization and operational testing of the complete system. And that's something that's industry practices. The NECA documents talk about the pre-energization tests and so forth, but now it becomes a requirement in the NEC. And by having it in Chapter 1, it doesn't matter if they're inside or outside feeders or branch circuits in the medium and high voltage range. They have to have the operational testing and the pre-energization testing and associated documentation that can be used for authorizing the equipment to be energized. Oftentimes, inspection authorities will require that documentation as a basis for their approval and release to allow it to be energized. Photo is an example of some equipment that is undergoing some tests. Chapter 2 is titled Wiring and Protection. This is where you find a lot of your overcurrent protection, your branch circuit limitations, feeder limitations, grounding and bonding, and so forth. We'll cover a few of these changes. I think the NEC historically sees expansion of GFCI requirements for dwelling units and beyond dwelling units each time we move from cycle to cycle. And the big one there we talk about this cycle is Section 210.8b, which applies to all single-phase receptacles rated 150 volts to ground or less and 50 amps or less, and three-phase receptacles rated 150 volts to ground or less and 100 amperes or less. These are new requirements for GFCI protection. Panel 2 acted favorably to expand those requirements. The shock hazards remain the same, and many of the equipment and receptacles that are installed in those wet or damp locations that create the shock hazards are at these higher ratings. And it was a likely provision to be added to the code. Panel 2 acted favorably to some substantiation and to increasing those requirements. And the manufacturers have actually responded over the last few code cycles with equipment that is capable of providing such protection, either in the single-phase mode or in the three-phase mode. The equipment is available. Section 210.11C4 is a new subdivision added to require at least one 20-ampere branch circuit to supply garage receptacle outlets. Prior to this addition of the code, you could supply your your garage in a dwelling unit with a 15 ampere general purpose branch circuit. You didn't have any specific requirements, but there's a lot of capacity needs these days, and Panel 2 recognizes additional tools and the requirements for tools and things that go on within a residential garage that really prompted this new requirement. Also, you'll see within this area of the code and a related provision, the restriction to supply an outdoor receptacle from the garage circuit in 210.52G1 was deleted. So what we end up with is the three requirements. The first one we just talked about, 210.11C4, requires a 20 amp branch circuit for the garage, which is a little more restrictive, gives it a little more capacity out there. We know from last code cycle that a receptacle is required in each bay of the garage, 210.11G1, 52G1 I mean, and then you have the exception that allows you to tap off of that circuit, which is GFCI protected anyway, to supply a receptacle that's on the outdoor or in an outdoor location at the garage. Actually, a really good requirement because it handles some capacity needs where the 15 ampere may fall short, and it also, having one in each bay, actually reduces the likelihood of abuse of cords and things that can create unsafe conditions. Staying within 210.52C, list item 3 has been revised to address not only countertops, but it also addresses work surfaces. And what was really changed here is the method of measurement when you're dealing with a peninsula countertop. No longer do we measure the distance from the connecting edge of the peninsula to the existing cabinets. They are supposed to be measured now from the connecting perpendicular wall. So the width of the countertop is now added to the peninsula countertop long dimension. We've got a graphic that goes along with that to show the comparison between the 2014 NEC and the 2017 NEC. Okay, so the measurement not taken from the connecting edge anymore, it's taken from the connected perpendicular wall. Panel 10 has responsibility for overcurrent protection, dealing with fuses and circuit breakers, and Section 240.24A deals with accessibility of those overcurrent devices. There's a revision here that clarifies that the switches containing the fuses and circuit breakers, not just the overcurrent devices, must be readily accessible with the operating handles not more than 6'7" high. Prior to this revision, it was just the overcurrent devices themselves, when it's actually clarifying the operational handle of the switches we're dealing with, and not the overcurrent device. And a new exception, and this aligns with the revised definition of the term readily accessible. There's a new exception here that permits the use of a tool to access overcurrent devices within listed industrial control panels. And the photo that you see is typical. 240.24A would certainly apply. You've got the disconnecting means in the panel board enclosure. On the right, no more than 6'7" high. You've got the main or the single disconnecting means in the industrial control panel in the right center, and you also have a smaller industrial control panel with looks like a manual on-off, and then you have a transformer over on the left. So an example of enclosures with a 240.24 accessibility requirements would apply. Section 240.87 was new a couple of cycles back, and it provides arc energy reduction requirements in the NEC. That new section 240.87 was the first time in Article 240 where we saw prevention through design requirements added to the NEC. And in this case, when you deal with larger equipment equipment with larger capacities that's capable of producing higher incident energy levels. Well, new in the 2017 edition of the NEC, the arc energy reduction methods now would apply to enclosures that contain fuses. In other words, fuses, in addition to circuit breakers, can be used where arc energy reduction is required. The requirement has a delayed implementation date of January 1, 2020 to actually permit and recognize that some manufacturers have to have the ability to ramp up and have their processes be compatible with the new provisions in the NEC. So main change here in 240.67, the same 1200 ampere threshold exists. So we're dealing with that level of threshold or greater where for breakers and fuses where arc energy reduction would be required. And it's all about providing a means to quickly de-energize something through a fast-acting fuse that acts so quickly that the amount of energy is highly reduced in a ground fault or a short circuit event. Moving into grounding, Article 250 provides the rules for grounding and bonding. And the first change we talk about here today is in 250.52a. That's the details and descriptions of electrodes that are permitted for services and systems. And Panel 5 acted not so favorably to recognizing metal in-ground. I'm getting ahead of myself here. 250.52 was revised and simplified. We're dealing with structural in-ground supports, whether they're encased or whether they're not encased. The change happened to align this section now with the definition of grounding electrode. The previous text related to structural metal building frames above the earth has been removed. It really hasn't been removed. It was actually relocated to section 250.68c. So what happens here is the structural metal member that's in contact with the earth is actually the electrode, or the structural metal member that's encased in concrete that's connected to the earth is the electrode. Anything above the earth in the form of a structural metal member is a conductive path to the electrode, and so it acts like a grounding electrode conductor. It's more appropriate that that information from 250.52a2 is relocated to 250.68c. So the whole change here is to not introduce anything new to the NEC, but to align this section with the definition of the term grounding electrode. And there's a graphic just showing what we mean. You know, the electrode is actually the steel that is in direct contact with the earth for 10 feet or more. And the same thing on the right, where you see steel that is encased in concrete that's in direct contact with the earth for 10 feet or more. This is the one I started talking about before in 250.52a. Section 250.52b has a list of electrodes or metal components that are not permitted to be used as electrodes. And we know aluminum is in that list. We know gas piping is in that list. What joins that list is a new item 3 and clarifies that structures and reinforcing steel for in-ground pools are not permitted to be used in the grounding electrode system for a building or structure. There was a proposal to actually recognize that it could be used, and Panel 5 did not react favorably to that. Instead, they basically said that it is even though it would resemble an electrode and it makes the connection to earth, they didn't want to purposely include it in the grounding electrode system. So we're talking about the in-ground conductive shell that's usually encapsulating rebar that forms the structure of an in-ground pool. All the requirements for creating a common bonding grid and equal potential bonding and so forth are still in play. Section 250-94 has been reformatted into two subdivisions. It was just one long requirement prior. Two subdivisions are now included. The new information is actually in Subdivision B. Subdivision A still includes all the information about the intersystem bonding termination device. Subdivision B recognizes other means, and a common other means that's used to accomplish a provision for communications, grounding, and bonding is a listed 1/4 by 2 inch copper bus bar that could be used in addition to an IBT. So if you had this type of arrangement installed for a communication system, it would be acceptable and now recognized in the 2017 NEC for use. Once again, the NEC catching up with industry practices. Keep an eye on this one. If I had to identify one of the more significant changes in grounding and bonding for this edition of the code, this would be it. 250-104A was restructured into a list format to provide a more logical layout, actually, and to clarify by adding some words if of sufficient size to A3 and A4. But the big change in this section is the minimum size requirements for a bonding conductor or jumper for metal water piping or structural metal framing member. So rather than use the maximum values in Table 250-66, the NEC now requires Table 250-102C1 to be used, which means that if you're dealing with a larger service or a larger separately derived system and you have to install a water pipe bonding conductor or structural metal framing member bonding conductor, you don't stop at 3/0 copper or 250 aluminum anymore. In the larger sizes, you have to apply the 12.5% rule. That's a significant change. So we're talking about a bonding conductor for piping systems that would be installed. 250-148, just a clarification here to take the word all and replace it with any of and all in this section to clarify that all equipment grounding conductors associated with the circuit conductors in a box must be connected together and attached to the box. The change really clarifies that connecting the EGCs together and to the box is not just for each associated circuit that would be contained within the box. So this clarifies that in the graphic it's very simple because there appears to be just one circuit. But if there are multiple circuits within the same box, the requirement now is to connect all the equipment grounding conductors together and to the box and associated device if it's required. All right, Chapter 3. And we're going to end, when I'm done with Chapter 3, we're going to end Part 1, and we'll open it up for any questions that you might have. The first change we'll talk about is actually a good clarification, and it relates to Table 300.5. Table 300.5, as everyone knows, is the table we lean on for minimum burial depth requirements for the various wiring methods we install. And there was a conflict that happened in the last couple of cycles between the manufacturer's instructions for listed low voltage lighting systems and what was required by the table, 300.5. So what we have is a clarification, and you'll see a superscript note that follows the table that's actually part of the table as a rule, clarifies that that the listed low voltage lighting system installation instructions can take precedence, and you don't have to follow the minimum requirements in the table if the instructions say otherwise. So those low voltage lighting systems that may be installed for landscape lighting, for example. You can follow the installation instructions and you're not tied to the values in the table. Another significant change in the NEC in Article 310 is the deletion of Table 310.15b3c. That's the rooftop adder, the rooftop correction factor adder table. That table has been deleted. We no longer are required to take a correction factor for installations of cables and conduits installed on roofs, except where they're in direct contact with the roof. Where the clarification and the wording in the code that actually appears is not direct contact, but actually introduces the 7/8 inch, where the distance above the roof to the bottom of the raceway or cable is less than 7/8 of an inch. A temperature adder of 60 degrees C has to be applied. So big change here. It was related to substantiation from large universities that were retained to actually look at historical data and look at some formulas and some methods that NASA uses for gauging temperatures and when to increase things in size and so forth. And also a look at historical data that dates back to the late 1800s and early 1900s when Table 310.15b16 was actually originally developed, and it was discovered that those tables within Article 310 were really conservative when the original code grade rubber conductive conductors were first introduced for our systems and circuits. So we're looking at this rooftop, and anything that is exposed to the sunlight or on the roof would no longer have to be taking a correction factor or a temperature adder would no longer be necessary as a result. Panel 6 acted favorably to that significant substantiation. Article 314 provides rules for junction boxes and pull boxes, and Section 314.28e has rules related to power distribution blocks. And the change here recognizes that a power distribution block could be used on the line side of the service or the load side of the service. So with that understanding, power distribution blocks that are installed on the line side of the service equipment must be listed and marked for that specific use. Remember that the amount of available fault current from the serving utility is typically a lot higher than if it were on the load side of an overcurrent protective device, and that's going to have an impact on the listing and evaluation and marking of a power distribution block that is intended for use on the line side of the service equipment. And the graphic just shows an example of a power distribution block. This one has the guards removed. Remember that when these things are used in actual field conditions, the completed installation would include a shield or a guard over those live parts. And the last one we're going to cover, and then we'll open it up to some questions, is Section 366.20. It deals with conductors that are installed in parallel in wireways, in this particular case, auxiliary gutters. New requirements for installing conductors in parallel exist when they're installed in those arrangements in auxiliary gutters and in non-metallic and metallic wireways. The change requires grouping of the conductors. So in other words, no longer can you just take a wireway or a gutter and just dump all the conductors of a parallel feeder or parallel branch circuit and install them in there without regard for the proximity of the conductors of the other groups. So the picture that we show is what appears to be a 10 by 10 or a 12 by 12 wireway that is flanged into an upright switchboard section. And what you can see, it looks like six 500s per phase that are used in a parallel arrangement. And what you see is each one of those sets is grouped with its associated phase conductors. And what this does is it minimizes the heating effects and the effects of imbalance, which could result in some conductors of the overall parallel arrangement being loaded more heavily than others because of imbalance. And as soon as you start disrupting the group and the canceling effects of grouping, you start ending up with additive current that can overload any single conductors in a parallel arrangement. So that's what prompted the reaction by Panel 8 to the favorable reaction to the grouping requirement for parallel conductors in wireways and auxiliary gutters. A little more planning involved if you're installing those types of arrangements. Okay, and that's the end of part 1.
Welcome to today's webinar, 2017 NEC Significant Changes in Review, Part 2. I'm your host, Timothy Johnson. I'm the digital editor for Electrical Contractor magazine. The audio for today's presentation should be coming through your computer speakers or headphones right now. If you prefer to call in, there's a toll-free number in the event info panel. If you have other difficulties, please feel free to reach out to me using your chat window at any point. Also, please note that today's presentation is being recorded, so if you miss anything or something comes up and you have to leave, you can come back at your convenience. In addition, all registrants will receive a copy of this presentation in PDF form when the recording is available or shortly thereafter, which that should be early next week, and you'll all be notified by email when it's ready. Finally, one final note, there will be a Q&A at the end of the presentation. At any time during this event, though, you can submit your questions through the Q&A chat box. So now on with the show. Today's webinar is the second part in a series that's all about the 2017 NEC Significant Changes. We broadcast part 1 on November 8th, and the recording of that webinar is available at ecmag.com. If you missed that one, it's okay. This presentation covers that second half of the code, so you can return to the first half at your convenience. At some point, we will also edit the 2 sessions together and offer a comprehensive video of the presentation. Our presenter today is Michael Johnston. He's NECA's Executive Director of Standards and Safety. Mike is the chair of the NEC Technical Correlating Committee. He served as a principal representative on NEC Codemaking Panel 5, representing IAEI for 2002, 2005, and 2008 cycles. And he's currently the chair of Codemaking Panel 5, representing NECA for the journeyman wireman. Representing NECA for 2011, 2014, 2017 NEC cycles. He is a member of the IBEW and has experience as an electrical journeyman, wireman, foreman, and project superintendent. Mike worked for the IAEI as the Director of Education, Codes, and Standards for almost 10 years. He also worked as an electrical inspector and electrical inspection field supervisor for the City of Phoenix, Arizona. Mike is an active member of IAEI and NFPA Electrical Section, Education Section, the UL Electrical Code, and National Safety Council. And after all that, he still finds time to contribute to and consult for Electrical Contractor magazine as our code expert and code comments columnist. So I want to thank you all for attending. Now I'm going to hand it over to Mike Johnson and get started. Mike?
Thanks, Tim. Just making sure you can hear me. Broadcasting okay?
Yeah, we can hear you just fine, Mike.
Perfect. Thank you. Well, it's a pleasure to be back to work on part 2 of this 2-part program on the 2017 NEC changes. And today we're going to cover
On November 8th, we covered chapters 1 through 3, and today we're going to look at highlights from chapters 4 through 8. What we've done is we've selected a nice variety of significant changes in those chapters, those latter chapters. We would be remiss if we didn't thank our sponsors, Fluke and Siemens, for stepping up and helping us bring this to you. So thank you to those two sponsors. They're always great contributors to NECA and NEC Magazine, and we always appreciate their help and hope that the broadcast reaches all of their viewers as well. So with that, I'm going to get right into it and start on some changes in Chapter 4. Chapter 4 of the NEC is titled Equipment for General Use. In the first article where we saw significant change is Article 404. Article 404 covers switches, all sorts of rules in 404 for switches, but the change in 404-2C deals with switches for lighting loads, and it deals with that recent set of changes requiring the neutral or grounded conductor be brought to each switch location for a lighting load. The phrase habitable room was deleted, which essentially expands the requirement for bringing the grounded conductor to switch locations, areas like bathrooms, hallways, and stairways, and so forth. And the whole idea there is to have a neutral conductor to connect the appropriate rated motion sensor that typically requires a neutral conductor to operate the brains of the device. The next thing you'll notice as a change in that section clarifies that the device connection must be made to a device where required. The change there was necessary because the previous rules only required that you bring the grounded conductor or neutral to those switch locations. It never talked about utilizing it, and that's been fixed in the 2017 NEC. A companion change to that one that requires the grounded conductor in the switch locations is a new section, 404.22, in Part 3 of Article 404. And Part 3 of the article deals with the construction specifications for switches. And there's new language that was inserted there to clarify that electronic switches, such as occupancy sensors and so forth, they're not permitted to introduce any current on the equipment grounding conductor, which is basically going to cause a change in the product standard for developing those types of devices. It's not as problematic when you introduce milliamps of current through one device on a system, but if a building has a few thousand of those devices, milliamps can turn into amperes real quick, and you really shouldn't have that level of current on equipment grounding conductors. There's a future effective date tied to this to give the manufacturers time to deal with those types of devices under the current product standards that are in the pipeline. Another change in 406, Article 406 covers receptacles, and there's a continued set of revisions dealing with the receptacles that are controlled by energy management systems. This is largely driven by the requirements in the ASHRAE 90 standard that requires a certain amount of receptacles to be automatically controlled by energy management. And in the previous edition of the NEC, we had the requirement for the universal power symbol on the receptacle, but to the normal user of the receptacle in the field who may not have knowledge of the NEC, it was unsure to many of them what that meant. The change requires the word controlled be included in addition to the symbol on the face of the receptacle. That gives the occupant a sense that the device is controlled, and in this case it's automatically controlled through energy management. So essential loads that you want to remain on all the time, you would want to refrain from plugging them into a controlled receptacle. You want to make sure that there's power there all the time. So that's the change, to include the word controlled in addition to the symbol on the face of the receptacle. Interesting challenges for the code panel because there's not a whole lot of real estate to deal with on the face of the device. Article 409 covers industrial control panels. A small change here to require, these things require a short circuit current rating to make sure they're not used on a short circuit that exceeds their rating. New requirements are for documentation that documents the amount of available short circuit current at the industrial control panel and the date of the calculation, and that documentation must be made to those authorized to inspect the installation, and obviously verifying that the industrial control panel has a rating and is used within its rating is important for the approval process for inspection authorities. This is a significant change in Article 440. Of course, Article 440 deals with air conditioning and refrigeration equipment. In the grounding and bonding area, a new Section 9 has been added to the article, and it requires a wire-type equipment grounding conductor for outdoor portions of metallic raceway systems that utilize non-threaded fittings installed on a roof. So what that means is if it's intermediate metal conduit, rigid metal conduit, or EMT, and we're using compression-style slip fittings, the equipment, wire-type equipment grounding conductor is now required, and substantiation to drive the change was related to physical damage to a lot of those raceways being subjected to through maintenance operations and so forth, where the equipment grounding conductor continuity through a metallic raceway could be impaired and loosened, as those conduits would tend to get damaged or be subject to those physical abuses. So by having the equipment grounding conductor contained, there's an increased amount of assurances that we will have an effective ground fault current path that is maintained, even if the fittings should loosen up under those types of conditions. So that applies to all metal raceways on rooftops, and it's only the exposed outdoor portions of those raceways. And many times designers and engineering teams are often specifying wire-type equipment grounding conductors anyway within those raceways. Chapter 5 is titled Special Occupancies, and a lot of changes happened within healthcare facility rules and some within the hazardous locations rules, so we'll hit a couple of those highlights for you. Article 514 handles motor fuel dispensing facilities, and a new list item 3 in section 514.3b addresses LNG, liquefied natural gas, compressed natural gas, and liquefied petroleum gas storage tank areas and locations. It's important to delineate the extent of the hazardous location for equipment selection purposes, wiring method selection purposes, and so forth. The new requirements also provide separation distances from property lines and from other gas storage tanks. Not uncommon to see one of those tanks backed up to a property line, and if there's electrical equipment on the adjacent property, it could impact the classification of the area and a type of wiring method that is not controlled from the property on which the tank is installed. So there's distances there now that must be maintained from those property lines. And the image shows a typical large bulk storage tank for gaseous fuels. Continuing in 514 motor fuel dispensing, Section 514.11 is not new, but it's been revised. It's titled Emergency Disconnects. And the changes in this section align with NFPA 30A, which is where that's the parent document for a lot of what you see in Article 514. But what happened here is it's divided into two subdivisions. Subdivision A addresses emergency disconnects for dispensing equipment and no longer addresses the circuit disconnecting means and breaking all conductors of the circuit for maintenance type of operations. That concept is handled effectively already in Section 514.13. So all you see that's left in here is rules that relate to locations and the requirements for emergency disconnecting means for attended stations and non-attended stations. The graphic just shows an example of a motor fuel dispensing facility, and the requirements are that there's an emergency disconnect switch that shuts all of them off or a group of them off, typically located for those users who are operating the fuel dispensing nozzles. Article 517 provides rules for healthcare facilities, and the changes I'm about to cover here actually were necessary in the 17 edition of the code to create a close alignment with the parent document, NFPA 99, which is the Healthcare Facilities Code. The first change brings the term governing body into Section 517.2 because the term is used within several rules in Article 517. So we have a new definition that aligns with the same definition in NFPA 99 to explain who and what a governing body is. And here's a look at that definition. It's a person or persons having overall legal responsibility for the operation of the healthcare facility, and they make decisions regarding what type of operating rooms, what type of locations, whether it's critical care, general care, what branch of the system circuits must be connected to, and so forth. So it's clear now that having the definition of governing body clarifies that there's some legal responsibility related to those rules. An example of a healthcare facility. There's a definition in 517.2. It's a multi-part definition, and it was previously titled patient care locations. And one of the things you're going to see throughout Article 517 is that the word location and the word area, as in patient care location or patient care area, all of that has been changed to spaces, and the spaces have been categorized. So no longer do we use the words or the phrase patient care area or patient care location. We use patient care spaces, and then we categorize them in categories 1 through 4 based on their hierarchy or level of care within each one of those locations. Once again, this change aligns with the parent document, NFPA 99. There you can see patient care space. You got basic care space, which is a category 3. And as the categories go down to 1, you see the level of care, the hierarchy goes up. We move to general care space, that's a category 2 space. And that would be an example of a category 2 space in a hospital, for example. And then you get into critical care. This is category 1. This is the most critical. These are spaces in which failure is likely to cause major injury or death to patients, visitors, or staff. And then there's support spaces, which has a category of 4. Here's an example of a critical care space, category 1, operating rooms. Obviously, it's a critical time for any health care provided to patients under anesthesia and so forth. Also, a new definition of invasive procedure should provide some clarification for users of the NEC to help them understand what invasive is. And basically, invasive is anything that's penetrating the body. It could be in the form of catheters. It could be in the form of opening the body up for procedures and so forth. But the new definition will help folks understand how to apply the rules where the term invasive procedures are present. And another change dealing with selected receptacles is in 517.2 to clarify who's doing the selecting. Now we have this definition governing body of the healthcare facility, and the definition of selected receptacles is now includes the phrase governing body. It really clarifies who's doing the selecting of the types of receptacles necessary for those spaces. That's a good clarification. Here's an example of a critical care location with life support equipment hooked up to patients, and there would be a number of select receptacles from the various branches, the normal branch, the equipment branch, and the critical branch that would be selected for those locations. Section 517.13a and b, that's in Part 2 of Article 517, dealing with wiring and protection. The change is extended into this section and other sections throughout Article 517 to change the word area to space. And within this section that requires the 2 grounding paths for branch circuits serving patient care spaces, there's a clarification about the wire type equipment grounding conductor within those metallic raceways. The words green along the entire length of the conductor have been added for clarification. There's also an exception there that talks about isolated grounding type receptacles, and that section was revised, that exception was revised to point to Section 517.16. So the graphic that you see is typical of what you would see in a patient care space, a branch circuit for the patient care space. The concepts in 517.13a and b are all about not having all of your eggs in one basket. You want to have 2 equipment grounding conductor paths. Path 1 is the metal EMT in this case. Path 2 is your contained insulated equipment grounding conductor that connects to the receptacle. I mentioned 517.16, use of isolated ground receptacles. This section was expanded, and this is related to how it appears. These rule appears in FPA 99. What you have is a prohibition in subdivision A. So that patient care vicinity, which is a defined space, it talks about 6 foot from the edge of the nominal bed location, and then it goes up to a height of about 7.5 feet. Within that space, isolated ground receptacles are restricted from being installed. Subdivision B goes along and it provides the requirements for isolated ground receptacles and installations outside of that defined patient care vicinity. So that's the major change here in 517.16 to clarify that you can install isolated ground receptacles and circuits in a healthcare facility. You just can't install them within a patient care vicinity, which is a defined, dimensioned location around the nominal patient bed location. Section 517.19, once again, the word space changes, or the word space replaces location in this section. And what you'll also see here is, in parentheses, the category 1 is used in here. And the revisions necessary to incorporate the changes, as we talked about earlier, to the definition and the categories align with how they address that in NFPA 99. There's another revision in this section to provide clarification that the identification of the receptacles in the critical care space has to be by a distinctive color or other marking to render them readily identifiable as a receptacle connected to an essential electrical system. The photo is, if you looked on the left side of the photo, you can see in the ceiling pod mounted surgical light apparatus, you see an area where power receptacles are included on the left side of the photo. So what you see is the color red is used in this case for the distinctive color for receptacles that are connected, in this case, most likely to the critical branch of the essential electrical system. Section 517.29 is new, and it provides an introduction to how the categories of essential systems are incorporated within the new Part 3, essential electrical systems, and the fact that the Category 1 type locations, Category 1 and Category 2 type locations drive the requirements for Type 1 or Type 2 essential electrical systems. So the Category 1 and Category 2 locations are based on the level of care in those locations. The types of the essential electrical systems are derived from and aligned with NFPA 110, which gets into emergency or essential electrical systems that are categorized by type. 517.30 is not new. It covers required sources of power. It's been relocated from 517.35 to 517.30 to provide a more logical layout, really. That's what's going on here. But there is a change in there to incorporate fuel cells. Fuel cells are now included as a source for an essential electrical system. If a fuel cell is used as a source, it must be listed for that use. And another important change that happened in Subdivision C in this section is to remove the subjective word consideration. The previous language in Subdivision C indicated that consideration should be given to the location of the power source for an essential electrical system, and really that was very subjective, and you had a lot of folks were playing with those words and replying to authorities having jurisdiction. When they asked the question about the location, they would say, yeah, I considered it, but I'm not going to change it. And it's all about continuity of service and making sure that you select a location that is not going to be subject to damage and possibly loss of power for an essential electrical system. So here's some of the language, how it should appear. You see sources of power, generating units is not new, but what is new is fuel cell systems. In Subdivision C, the language ended up reading something like essential electrical systems components shall be located so as to minimize the effects of anything that might interrupt that power source. Instead of consideration shall be given to the location of those components. We're talking about sources like generators and batteries and so forth that are essential to keep the facility running. Healthcare facilities are often designed around a defend-in-place philosophy because loss of power doesn't mean we're evacuating the building. Our essential systems operate and function a lot differently in healthcare facilities. When you get into the later parts of Article 517, Section 517.42 requires that a Type 2 essential electrical system be installed for nursing home and limited care facilities. Obviously, you move out of a hospital where you're dealing with a Type 1 system there. The level of essential electrical system is not as great because there's not as many critical care procedures going on in those locations. It's more about nursing home and rest and limited care facilities for folks that need limited care. One change that you'll see is to remove the critical branch from the symbols and the figures in that part of the article, and any reference to critical branch from the rules is no longer necessary because a critical branch is not necessary for a Type 1 essential electrical system. Separation is still required between the equipment and life safety branches, and once again, clarification there that identification is required for essential electrical system receptacles or the plates, and if it's by color, the same color needs to be used. Red is often the color to be used, but the NEC nor NFPA 99, neither one specify a color. Moving out of healthcare facilities, Article 590 provides rules for temporary power and temporary construction power and so forth. There's a small change to actually align with common practices in the field to allow Type SE cable, which includes Type SER as well, permitted to be used as a temporary wiring method in underground raceways. The thought process here is that while SE and SER are not permitted in permanent installations, they certainly can serve well in an underground raceway during the period of construction because they're required to be removed once the construction is complete. So Panel 3 acted favorably to allow it because there's a time restraint on it. Another change in 590.4, Subdivision G, recognizes that MC cables are permitted to be used as a wiring method as long as, and you don't have to install a box for any splice points, as long as grounding continuity is maintained from length of MC cable to another length of MC cable. And this is often accomplished by using a suitable listed MC cable connector. Now this goes back to Article 590 where it talks about you don't have to have boxes on your splices for temporary wiring. The concept is it's going to be removed eventually, so you keep your splices up in the ceiling out of harm's way, and you don't have to put them in a box. When you're using MC cable, oftentimes equipment grounding is accomplished by continuity of the armor, if it's AC cable especially. Chapter 6 in the NEC addresses special equipment, and the first article in Chapter 6 covers signs, electric signs, and outline lighting systems. And there's a small revision here to make it clear that retrofit kits are within the scope of Article 600. And when you see 600.3, it talks about listing, and the scope talks about outline lighting and sign and retrofit kits that are required to be listed and marked. And when you have a listed sign that's being changed, say for example from fluorescent technology to LED technology, oftentimes there's retrofit kits that can be used for that purpose, retrofit kits are required to be listed and marked, and it's all about compatibility. We want to make sure that the retrofit kit being installed in a sign to bring it up to current technology, and it's listed and suitable and it's been evaluated for that purpose. Another change in Article 600 is to include a new section 634, that deals with PV-powered sign installations and installation instructions. PV-powered signs you see them a lot in the right-of-ways. You see them in traffic areas where signs and electric lighting in the right-of-way are installed, but they also can be installed on private property as premises wiring systems. There's requirements in there about the output wiring, and of course a listed and labeling requirement is there. Must be suitable for the PV application, so the type of cable that you're using for output conductors is impacted there, and they must be routed to follow the sign or body, the sign enclosure, short as possible on the output conductors and protected wherever they're subject to physical damage. And you can see the sign to the left in the image, and some of them output conductors that are making entry into the bottom of that enclosure on the right side of the pole. Another area where the code is catching up with current technology is in electric vehicles and electric vehicle supply equipment. The product standards and equipment related to wireless power transfer and wireless charging systems and equipment is now, it's growing and going to grow in popularity, and the NEC is being equipped nicely to handle and have rules that apply to those systems and installations. So 2 new definitions of wireless power transfer to tell the user of the code what that is. Basically, there's no contact with wire between the vehicle and the supply equipment. And then the electric vehicle supply equipment, it's wireless power transfer equipment, consisting of a charger, power converter, primary pad, and the 2 devices that are either of the following: interconnected by an output cable or suitable conduit system, or contained within a single enclosure without an output cable or other suitable wiring means. But what we're looking at is the ability to transfer power wirelessly through a magnetic couple. Article 680 covers swimming pools and other similar bodies of water. And 680.10 has been a long-standing requirement in the NEC, covering specific burial depths and for conduit and wiring methods that are installed within the vicinity of the pool. And Panel 17 acted favorably to remove that because the wiring depths were effectively covered by Article 300, and specifically Section 300.5. So we no longer had the same requirement that appears in both locations. The idea behind maintaining at least 5 feet of distance from the pool is one that relates back many years, and when there was concern about induced voltages onto a rebar cage of a pool system. It's no longer a concern. There isn't any substantiation to continue to require that, so Panel 17 has removed it, and thus the rules in Chapter 3 for burial depths now take over its place. Something else that's new in 680 is a Part 8, and this new part addresses electrically powered pool lifts to provide accessibility to the pool for those that are physically challenged. And the installation of the lift often occurs across the country for compliance with other regulations to meet accessibility requirements, for example. Some of them have electrical power sources. Often it's in the form of a low voltage system providing power to them. But nonetheless, Panel 17 was concerned enough about them that they should be addressed by the National Electrical Code so that whatever type of lift you're putting in there that's electrified, battery powered, or other should meet requirements and product standards and should be listed for that use in that location. A big change, this is a change that actually has evolved over the last couple of cycles. 690.12 is a section that deals with rapid shutdown for photovoltaic systems. And essentially what you have is a requirement where a PV system is installed on a building, a rapid shutdown feature must be provided. And it's driven by firefighters. They actually were behind a lot of the substantiation because when they roll to a facility, they have a ready means to disconnect power, usually in the form of a main breaker at the service or something like that, or main switch. When you shut the power off and you have a PV system on the building, the PV system is still providing output power. You have to actually blanket the PV modules to get it to shut down. And the concerns are if they're ventilating a fire and they're on a roof and they're chopping through with their axes, they're exposed to the output side of those systems. So rapid shutdown is evolving. The change here was to separate the parent techs into 4 first-level subdivisions, and there's a new area boundary term that's used in there, and the rapid shutdown features apply both inside and outside the boundary. And what we're talking about is any controlled conductors on the output side of the inside the boundary, or not more than 3 feet from the point of entry of the building, need to be reduced to 80 volts within 10 seconds, which is a reasonable amount of time to reduce the output to a level where, a DC level where injury and death is less likely to occur. So while the NEC is not a retroactive document, this will apply to new installations on buildings or structures. So if folks have quite a bit of property, they might want to consider installing their PV systems on the ground and then run the output side to appropriate disconnects that are installed on the building, and they reduce the likelihood of one of those events happening to them. Article 691 is new, and this was necessary to provide a set of rules for large-scale photovoltaic electric power production facilities that are being installed in numbers across the country in areas where the sun shines a lot. The Southwest, the deserts of the Southwest are a prime location for these things. And they're designed for supply of power directly to the electrical grid. And these are in the megawatt size. There's a couple in the Southwest at the 500 and 600 megawatt level, and they tie directly to the grid. And they're different from building mounted or other decentralized solar power applications, and they're supplying at the utility level. The problem with it is there's a lot of large systems and a lot of design criteria used for these systems that are installed, and Article 690 really was incapable of providing the rules necessary for these systems. So that was the birth of Article 691, so that there's rules for these systems that are installed typically by private owners and actually owned by by entities other than a serving utility. But certainly a utility system could be built to these rules as well. In the photos I have are actually a large-scale PV system. What you see looking down this road is all related to the PV system. This is at the 35 kV level. What you see on either side of the poles is the PV array, and that goes as far as the mountain. Standing right in that location, looking 5 miles in every direction, that's the large-scale PV system. And there's multiple inverters, and you know, from the combiner boxes, they send it into this inverter house that houses the equipment, and it changes it to AC, and it steps it or sends it to a transformer on the left side there that you see, a green transformer. And from there, it steps it up to the 35 kV level. We send it down the street to a substation, and then from there, they transform it up to transmission levels. It goes from 35 to, I believe, 230, and then from 230 to 500 kV. Large scale. Article 695 provides rules for fire pumps, and we see a change here to require listed surge protective device be installed on fire pump controller. The substantiation pointed out that about roughly 12% of the fire pumps tested after they were initially installed had damage due to voltage surges. So last code cycle, we saw a new requirement put in place for switchboards and panel boards used on emergency systems to have surge protection as well. A lot of this type of equipment has sensitive electronics in it and can be vulnerable to surge events that can cause damage. So requirement is now in place for surge protection on fire pump controllers. Chapter 7 in the NEC covers special conditions. I got a change or two here, and then we cover Chapter 8 and open it up to some questions. First of all, definition is new branch circuit emergency lighting transfer switch is a device connected on the load side of the branch circuit device. In other words, on the load side of a breaker, typically, it transfers only emergency lighting loads from the normal supply to an emergency circuit. It's not, we're not transferring a feeder in this case, it's just a branch circuit. And that new definition of branch circuit emergency lighting transfer switch is accompanied with luminaire directly controlled, which is an emergency lighting luminaire that operates on constant power. Often they're used for night lights, but they're also capable with control leads for integral dimming or switching functions. So in theater type applications and so forth, you can still control the emergency lighting, but when the power is lost and it has to switch to the emergency mode, it's driven to full brightness so that we don't leave the area in total darkness. So a couple of new definitions of terms that were used within Article 700 dealing with emergency systems. Article 706 is brand new, and it's titled Energy Storage Systems, and the common one we're seeing right now in the business is batteries, all sorts of battery technologies, whether it's lead acid, flow batteries, nickel, cadmium is a kind of an older technology, but lithium ion, lithium polymers, and there's other new technologies. But this covers all of that, but it also has coverage of electromechanical storage systems, which could be capacitors or supercapacitors, flywheels, compressed air, and so forth. So the NEC being equipped nicely with rules to apply to these energy storage systems, which that's a key component of handling demand response, taking care of smart grid initiatives and so forth. And so we're going to see a lot more battery storage and energy storage installed on the premises, but also you'll see utilities dealing with it in larger scale operations such as at substations and so forth, to handle areas where demand is necessary. Instead of using peaker plants, they'll be converting a lot of peaker plants to energy storage plants that utilize battery technology. Battery technology is advancing at a rapid pace, but so do the product standards have to advance at a rapid pace to keep up with it. Some of the new technologies in the failure modes fail pretty violently, so the building codes and the electrical code have to stay current with that to make sure when these systems are installed in buildings and structures that they're safe for the occupants in those structures. What you see here is a newer battery technology, and here you see a look at some older wet cell type battery technology. Article 710 is new, provides rules for standalone systems that are off-grid. It was never really clear that you had to comply with the NEC if you weren't connected to the grid, and this small article makes it clear that you should be complying with the electrical rules in the NEC if you're building a property with standalone power systems. In Article 712, we talked about in Part 1 when we mentioned the new articles, direct current microgrids, a brand new article. It's a distribution system consisting of one or more power sources, usually a wind system and a PV system, are connected in conjunction with the utility and controllable by a customer to dial in the amount of renewable energy system use that's taking place as compared to whether you're using the full utility capacity. So we're going to see a lot more common use of these grids, and they're very small. Some of them are very small within buildings. Some of them could be at the neighborhood level size, campus level size, and so forth. Microgrids is a common location where you'll see energy storage systems applied as well. 725.144 is new, and it was added to address Class 2 and Class 3 circuits that transport power and data to a power device. In other words, we have to make sure that we're controlling the amount of power that's being used over these types of cables. And there's a new table, 725.144, that lists the allowable ampacities based on the conductor sizes and types and number of cables bundled within the installation. For example, if you're using this type of cable and you start transmitting or transporting power within this type of cable, you can see where there's, with this photo especially, where you could get into a problem depending on the amount of power being used in addition to data within the same cable. You start bundling and you start having problems with heat. 770 is fiber optics. Under mechanical execution of work, the protection against physical damage is required to be in accordance with all of 300.4, not just 300.4 D through G, and that applies for fiber optic or optical fiber cables. And the last change, and we'll take some quick questions, and then Part 2 will be over. A new Part 6 has been added to Article 840 to address PoE, Power over Ethernet. That's a buzzword that you'll hear out there. Section 840.160 requires compliance with 725.144 for Power over Ethernet cables. New 840.70 provides listing requirements for Power over Ethernet sources. So we're going to see some evolution in this area. This is not something that's new, but it's actually seeing expanded use, and the NEC has to be equipped to be able to address installations where not only are we running Ethernet that is used for data and communications, but in some cases within the same cable we will be sending power to the various devices in our system and powering them up through that same cable. So that's what's meant by power over Ethernet. You can see the various devices here, whether it's a camera or other type of device. But not only are we sending the communications and signaling circuits to it, but we're also including power to drive the device itself. So that's what we have. Chewed up almost all of the hour. It goes quick when you're trying to fit in a bunch of information about the NEC and what's happened. Once again, I'd like to thank our sponsors, Fluke and Siemens, for teaming up with our host, Electrical Contractor Magazine, to bring you this short series of changes to the 2017 NEC. And with that, we can open part 2 for a few minutes on some questions. But if we don't address all your questions, feel free to email them to Tim, and he will forward them to me, and I'll be happy to answer them so you all get your questions answered. So with that, Tim, if you're still on board, I'll turn it back over to you.
Yeah, I'm here, Mike. So we got a few good ones, but you know, feel free to shoot them over using the Q&A box if you have a question. First one is, how often do code-making panels talk about minimizing subjectivity? What's the best way to address an AHJ who I believe is making an incorrect subjective interpretation?
Well, those are two interesting questions. The first one, how often do code panels address submitted changes? That happens on a cyclical basis. Every 3 years, the code is updated, so the code panels are looking at public input every 3 years. And based on the substantiation and the needs, they're incorporating them into the NEC. The other one is something that's beyond the scope of this program, but I always found that, you know, having worked as an AHJ and having worked as a foreman and an electrician myself, I always found when you have a gray area in the code or there's an area of questionable interpretation, it's always good to get the responsible parties together on site at the location and then come up with a reasonable understanding of attaining substantial code compliance. And I know sometimes it's difficult when a wireman is face-to-face or a foreman is face-to-face with an authority having jurisdiction. You have to realize that 90.4 says that they have the final interpreting authority. And that's a big responsibility, and it doesn't come lightly to a lot of jurisdictions. But one good way to handle it is to ask for it in writing and have them give you the code section. And, you know, have them help you understand where the rule comes from, and give it to you in writing so it's clear what you have to do and why. That's the best way, get it in writing.
Cool, okay. Next question. Regarding wireless power transfer, is the NEC only concerned with power transfer between equipment and electric vehicles?
The NEC is concerned with the equipment used to do that. And it has to be paired up with the type of onboard charging equipment that the vehicle would be equipped with. This is, as I said earlier when we were talking about that change, this is an area that is actually evolving. And the manufacturers of the vehicles have to work closely with the electric vehicle supply equipment manufacturers, in other words, the charger manufacturers, to make sure that the type of equipment installed on the premises is compatible with the type of charging system that's on board.
Okay. One more question. Well, let's do two ones. The next one, the second one will be pretty quick, I think. Regarding rapid shutdown for PVs, do the switches need to be on the panels as the image showed, or what are the restrictions there?
Typically what's going to happen, when you look at the new 2017 NEC, there's actually some diagrams that are shown that will show you some signage and information on the signage for the first responders so that they're clearly directed to the rapid shutdown. But it's typically going to be a device that's going to be in the vicinity of the service equipment. So when they're looking to shut the main power, they can initiate disconnection of the PV system by the rapid shutdown device. And my guess is, based on some of the discussions by the technical committee, is that in some cases this, depending on the type of system you install, it may be automated and interconnected with relays and so forth on the more sophisticated systems. So there'll be a variety of ways you can do it. The NEC was expanded greatly in this area, and I'd encourage you to take a look at that close. And the design teams are going to have to be real familiar with it as well to make sure that they meet the objectives. And those voltage levels and the time that the system has to come down to that lower output level, those are the critical features. The location typically is going to be at the service, the electric service location. Okay,
cool. And one final question real quick, because I know it's now 3:01, so we got to wrap this up. But
yep.
What was the installation that the large PV farm where the modules went to the mountain? Do you remember?
It was in Palm Desert. I believe it was Desert Sunlight, and that was done by a private contracting group. It was done a little bit north of 500 kV transmission line that went through that area and actually would connect to that line. So that's where it was, not far from Palm Springs.
Perfect, cool. Okay, well, it's about that time, so I'm going to go ahead and wrap this up. So on behalf of Electrical Contractor, I want to thank everyone once again for attending. I want to thank our sponsors, Fluke and Siemens, for supporting awareness and education of the NEC. I also want to thank Mike Johnson for an excellent presentation. I know both parts of this webinar series are valuable to our listeners, and will continue to be a value as a reference and educational tool for the future. Be on the lookout for the recording, which you'll be notified about in an email early next week, probably. Part 1 recording is already available, so if you missed that, you can go listen to it. And we also should mention, Mike, again, that you're in the middle of a update series in your code comments column right now, so look for that in the magazine. And yeah, I'm going to go ahead and end the event. Thanks everybody again for attending, and we hope to see you in a future webinar.
Thanks, Tim. Happy to do it. Enjoy, everybody.
Yep, thanks, Mike, and safe travels, all right?
All right, you bet. Thank you.
All right, take care. Bye.